This is a new chapter, 7.1, Elementary Algebra, Reducing Rational Expressions to Lowest Terms. All right, this is 7.1a, and a rational expression. If you remember from a long time ago, in fact, chapter 1, we talked about that, and it's basically, just putting it real simple, one number or expression over another when you can make it into a fraction. So even something like this is a rational expression, or that whole thing is a rational expression. Okay, so when you can put something on top and something on bottom, and that something on bottom cannot be a zero. It cannot equal a zero. If it does, it is called undefined, and there is no number that exists. So something to keep in mind, and we'll get to some of those shortly. First section is evaluating a rational expression. Whenever you hear the word evaluate, it usually means they're going to give you something like this, example 1, and they're going to say evaluate. They're going to say, what is the answer if x is 3 or if x is negative 2? So we're going to do this twice. They're going to put in a 3 and we're going to put in a negative 2. So we put in a 3, and I always, again, like to use parentheses, over 3 squared minus 4. So we get 9 minus 18 plus 9 over 9 minus 4 is 5. Okay, 9 minus 18 plus 9 is 0. So we get 0 over 5 for our answer. Any number with a 0 in the numerator is 0. So that ends up being the answer. Alright, so let's go and do if x is negative 2. We'll just keep with the yellow. Okay, we look at that. And it's a 0. Whenever 0 is in the denominator, it is undefined. It's the null set. There is no answer. Nothing exists. Okay? So that's evaluating. It's just putting in the number that they give you into the problem and seeing what it spits out. Okay, so in example 2, it says in the introduction to this chapter, we saw that the average cost per check of writing X checks in 1 month at a certain bank is given by the rational expression. So basically they're just saying, here is the formula. We don't really care if we understand exactly what it means. That's the formula. And it says, find the average cost per check if 8 checks are written in a month. Okay, so what we're going to do is we're going to replace X with the number 8. X is the number of checks written in a month. And we're just going to solve it from there. So we do the multiplication first. And that equals 3.20 divided by 8, which equals 0.4. So the amount it costs per check is 40 cents. 0.40, or you could write it as 40 pennies, 40 cents. So this one is in dollars, 0.4, not quite a half a dollar, and this one is in pennies. Brings us to restricting the variable. What restricting the variable means is that there are some problems, like this first one they give us, where there's a restriction there, meaning any number for x that will make the denominator 0 is our restricted number. We cannot have, we can use any number in the whole history of the universe except what makes that 0. So what makes that 0? A 3. 3 minus 3. So x can be any number in the whole wide world except 3. That is the restriction. So when I say state the restriction, I'm asking for that. X cannot equal 3. That is the restriction. That's the only number that it cannot be. Okay, brings us to example 4. We have 5 over x squared minus x minus 6. And what are they saying here? Determine any values of the variable for which the rational expression will be undefined. Okay, so what we're looking for is what numbers will make that expression 0. Okay, and this number, remember that exponent right there? That tells you how many numbers there are that will make that 0. So there are two answers we're looking for. So what we're going to do is we're going to break this up into two binomials, and we're going to use 3 and 2, negative and plus. So negative 3 times negative 3 times 2 is negative 6, negative 3 plus 2 is negative 1. So that's it. So what is going to make that 0? A 3. What's going to make that a 0? Negative 2. So the restriction is x cannot be 3 or negative 2, because either one of these numbers, when you put it in here, will make that 0. And you cannot have 0 in the denominator. So what we do is we just write x cannot be negative 3, x cannot be negative, not negative 3, just positive 3, and x cannot be negative 2. Okay? Okay, so this next section is called reducing rational expressions. Alright, so there are two properties, middle of page 449. Multiplying the numerator and denominator by a rational expression by the same non-zero quantity will not change the value of the rational expression. Okay, property 2, let's just read it. Dividing the numerator and the denominator of a rational expression by the same non-zero quantity will not change the value of the rational expression. Okay, so let's talk about what that means. If I have 6 over 15, and it says if we have a rational expression, and if we multiply the numerator, and we multiply the denominator by the same non-zero number, it will not change the value. Okay, it'll make it a bigger fraction, but this fraction will always be able to be reduced back to that one. Okay, so that's the main thing that we're talking about. You can multiply any fraction by any number as long as it's the same number on top as on the bottom, because what is 2 over 2? Any number over itself is 1. So actually what we're doing is we're multiplying that by 1. So it's not changing the value, because whenever you multiply something by 1, it doesn't change the value. The way I teach it is it just changes what it looks like. Does not change the value, it just changes what it looks like. And this will reduce back to 6 over 15. The same is true with a division. So let's look at what we mean by that. So it says, dividing the numerator and denominator by the same non-zero number will not change the value. This and this are the same thing. It's just this is the reduced version of this. Okay? Because what did we divide by? We divided by 3 over 3, and 3 over 3 is the same as 1. Okay? So it did not change because we divided it by 1. Alright, so that brings us to doing, the next example here, if I can get rid of my stuff. And this example says over Alright, what they're asking us to do is reduce that. So what we're going to do is we're going to use everything that we've learned before, and we're going to reduce that. If you remember a while back, this is the difference of two squares. I can take this number times itself and get x squared. I can take this times itself and get 9. And there's a minus sign, so x plus 3, x minus 3. Okay, so we're just simplifying the top, and then we're going to simplify the bottom. So we have an x and a 3 and a 2 and a plus and a plus. Okay, now that we did that, we are going to, I'm going to do something that's not really the best way to explain this, but we're going to go that way anyway. And I'm just going to say we can cancel, because x plus 3 over x plus 3 is the same as 1. Okay? So if this is 1 over 1, it can go away, because 1 over 1 does not change the value. That leaves us with this. Okay? So I just give you a minute just to kind of soak that in. And that brings us to example 6. 10a plus 20 over 20 minus 5a squared. Alright, so let's go ahead and look at the top here. What can we do to that top? We can factor a 10 out, and we're left with that. On the bottom, what can we factor out of that? We can factor out a 5, and we're left with 4 minus a squared, right? Now, if you remember, 4 minus a squared, is there a number we can multiply by itself to get 4? 2. Is there a number we can multiply, or a letter we can multiply by a to get a squared? A. So if there is, then we write difference of two squares, and we've got our 5 there. Okay, so let's write what we have. 10 times a plus 2 on top, and on the bottom we have 5 times 2 plus a and 2 minus a. So what can we do? We have an a plus 2 and a 2 plus a. Those are the same thing, right? They're just in different order, but since they're addition, doesn't matter. Leaving me with 10 over 5 times 2 minus a. 10 over 5 is the same as 2. So 10 over 5 is 2 on top over 2 minus a. We cannot cancel that in this. This minus sign, a plus or a minus sign, locks numbers and letters together. Okay, so you can't separate them. You could like we did over here, you can cancel this and this, because you're canceling both of them, both the a and the 2, because they're connected. They're chained together with a plus or a minus sign. If they're multiplied, they're not chained together. You can cancel all you want, but if they're added or subtracted, the only way you can cancel is if you cancel both of them. Over here, can't cancel those, because this is connected. Unless you can cancel both of these, the 2 and the minus a, you can't cancel. So we're kind of done at that point. Okay, which brings us to example 7, and we'll start on that in the next video.